Substance. Stories about the stuff that shapes our world.
When you go outside, like in the car and the public transport buses, everything is made out of plastic. So I can't really imagine a world where plastic does not play a role.
Substance.
Plastic, a material that seems too good to be true, right? It's flexible and durable. You can mold it whichever way you like and use it to craft almost any product you can imagine. But there's a catch. You see, once they've been created, plastics are extremely difficult to get rid of. Most plastics end up in landfills or are burned, and the recycling process is far from straightforward. If we want to keep enjoying the benefits of plastics without harming our planet, we need new solutions. Today, we're exploring new ideas that could help us live more sustainably with plastics. I'm Joe Hanson, and this is Substance, a podcast about the discoveries and innovations in chemistry and beyond, helping us build a sustainable society for the future. In short, we tell stories about stuff that shapes our world. And in this episode, we're talking about plastics and a new idea about how to recycle plastics that are currently burned or destined for landfills. So plastic is woven into the fabric of our daily lives. But here's the problem. Only about 9% of all plastic ever produced has been recycled. And just 1% has been recycled more than once. Most of it's still discarded or pollutes the environment. One of the biggest challenges is there's no single solution because different plastics need different recycling methods.
So yeah, a world without plastics is very hard to imagine, but I think there is a lot to be done to make them more sustainable on the long term.
I personally believe that there won't be a world without plastics. Yeah, so there are so many advantages. It's not just in the automotive where we talk about lightweight and safety and comfort. It's everywhere where we need plastics to keep our life standard that we have. And it's also to make our world more sustainable. But if we want to stick to plastics, we have to solve all those negative aspects.
That's where people like Matthias and Wiebke come in. They're both dedicated to changing how we deal with plastic at the end of its life. Together, they've developed a project championed by BASF to close the loop on plastic's life cycle. Their vision is instead of burning or dumping plastic from old cars, instead break it down into its smallest chemical building blocks and use it again. This is called chemical recycling.
My name is Matthias Kuba. I work at the research institute BEST, which stands for Bioenergy and Sustainable Technologies. And I'm leading a research group on gasification and synthesis there. I'm also a professor at the BOKU University in Vienna, which is like a University of Natural Science and Technology here in Vienna.
BEST is an Austrian company based in Vienna. They were the ideal partner to support BASF with their ambitious goal of transforming so-called automotive shredder residue into new raw materials and using it for the production of new car components. Automotive shredder residues are the plastic leftovers of something that used to be a vehicle, a tangled mess of materials like foams, plastics, films, even paint particles. Traditionally, this waste only had one destination: incineration or backfilling. Too complex to recycle mechanically, the traditional and commonly used recycling method, it leaves behind a pile of unused resources just waiting for a second chance. Their idea was to use what's called chemical recycling.
My focus lies on chemical recycling, which also means that we're looking at all of these plastic fractions, so all of these plastic residues that are currently not being recycled at all. And I think that's a very, very interesting field.
So as mentioned earlier, automotive shredder residues are the plastic leftovers of something that used to be a vehicle. Though we think of cars as mostly made of metal, you might be surprised how much of a modern vehicle is made of plastic.
Just imagine back in the 50s where you have had no polyurethane sheet, you would have sit on a shredded coconut husk that were just glued together. Or if you would have been in the good position to drive a luxury car, then it might have been horsehairs that were glued together. But you can imagine that won't be really comfortable. So no one of us would like to go on vacation in such a car. And it was even not scalable. That's the reason why it's so important to have plastics in your car.
Like many other products, plastic helped make cars more affordable and easier to produce for more people.
Today, we have roughly 200 to 250 kilograms of plastics in our car, depending a little bit of the size, of course. But that means also more or less 2,000 different parts that are made out of plastics. And that results in more or less 15% of the weight and 50% of the volume of a car that is made out of plastic. And you see that really everywhere.
That's Wiebke Speckels. She works for BASF and is dedicated to keeping plastics in the loop. Make them, use them, recycle them, and then use them again as raw material. The recycling of plastics in a car is not as easy as one might think. To get to the bottom of this, we need to understand how car recycling even works.
So honestly, that's quite manual work that is happening on these recycling plants. And to be fair, most of the recyclers don't have any interest into the plastics. What they do is they do the steps they have to, because by law, by legislation, they are obliged to get rid of all the fuels, of all the liquids that are in the car. Then they have to make sure that the airbags will no longer be active. So that's all the parts that they start to remove. Then with some good luck, they remove also the bigger parts out of plastic. So like the bumpers where you have a monomaterial that is already, as of today, recyclable. But the main portion of the car will get into a big shredder. And then it's just scrapped down.
Scrapped down. Eaten by a giant machine that cuts through metal as if it were butter. And when the process is over, the sorting begins. Because there is one material in the cars that's already valuable on its own.
And the interest that they all have is to get the metal out of that, because that's where today already is the value in. Yeah, so they can sell the metals that are already reused. That's also the reason why so many automotive manufacturers tell you that a big portion of your car is recycled. But this is normally coming from the weight of the metals. It's not coming from the plastics, which is by far the bigger portion with regard to volume. But due to the fact that metals are heavier, not by the weight.
Unlike the metals, some of the plastic parts in a car typically end up in a landfill, backfill, or an incinerator, where they're burned to regain energy. That's the fate that most of our household plastic waste meets, even in regions of the world where recycling is common.
Then there will still be a portion where you will not be able to sort that out. Remember, in the beginning, I said 2,000 different parts are made out of plastic. So we won't get all these tiny nitty parts back sorted. Meaning we will have a mixed fraction of plastics. And for those materials that are not seen as non-recyclable today, we need technologies like gasification, where you really can deal with those fractions.
And gasification is where Matthias and the BEST team come in. Gasification is a chemical recycling process that breaks plastics down to their molecular building blocks.
I always use the metaphor of plastic being like a big Lego structure. So you have a very complex structure with a lot of different molecules being strung together. In our reactor, what basically happens is we're breaking down all of the molecules into the basic building blocks. So like throwing your Lego structure on the floor and then picking up all of these single building blocks and thinking about what else to do with your building blocks. So you're basically breaking down a very complex structure into very simple building blocks.
The gasification plant that BEST built is in the heart of an industrial zone of Vienna, surrounded by a wastewater treatment plant and a good old combustion unit where garbage is burned.
Burning carbon sources, especially fossil carbon sources like plastics, has a big downside because you're always adding more and more CO2 into the atmosphere. So on the other hand, of course, it's a way to get rid of plastics, so to say, and by getting rid of plastics, also gaining at least some energetic benefits from it. So you could produce electricity or you could produce district heating when burning plastics. But on the other side, you're losing carbon as like a building block. So while incineration is a very good way to deal with plastic waste today, it still lacks the ability to actually use carbon in a very beneficial way.
Matthias and the team from BASF wanted to prove that this technology works on a bigger scale and with different materials fed into the process than originally planned. We're talking about automotive shredder residue, a mix of coatings, different plastic types, even wood.
So when you look at it, it's like a plant of 16 meters in height. There is like all of the units that you could find in industrial plants. However, it's still a little bit smaller than a very large-scale plant. The idea of our plant is basically to show that the technology does not only work in laboratory scale at a university, but can be operated 24/7 in continuous operation, like day and night, basically in an industrial relevant scale already. Our technology was actually developed for biogenic materials. So the first iteration of the technology, this is roughly 25 years ago, was designed to handle woody biomass. So basically wood chips or forestry residues, logging residues, mainly like of the realm of forestry. Then it was further developed to handle more biogenic waste materials, so biogenic waste from industry or from agriculture. And in the past couple of years, we actually redesigned our reactor system and we further developed the technology towards plastic waste.
The idea that we have had was to prove that we can use these complex mixed plastic waste streams in a high temperature recycling process over a certain period. So it was the first time that we have combined bio-waste, that's what BASF normally gasifies, with automotive shredder residues, that's this mixed plastic waste that we just talked about.
In Vienna, BASF's pilot plant runs day and night, producing a synthetic crude oil, or syncrude, from biogenic materials. And now, for the first time, some of that is also being made from those shredded automotive plastic parts. It's not enough for industrial scale yet, but it proves the concept. Plastic waste can become a valuable resource again. This syncrude oil can replace fossil resources in chemical production, helping companies like BASF make new products from old plastic.
Yeah, so as I said in the beginning, we're not yet an industrial plant. So our production capacities are, of course, much, much smaller because it's a research and development plant. But when we operate our plant here in Vienna, we get 1 barrel a day of product. 1 barrel being roughly 160 liters of product. I mean that our product can be used for demonstration cases.
The syncrude oil produced in this demonstration is an almost perfect replacement for naphtha. It's a certain type of gasoline. And naphtha is what chemical companies like BASF need for their chemical plants.
These are quite big chemical plants with a lot of different production sites. They are linked with thousands of kilometers of pipes because the side product of the one will be reused by the next one. And what they have in common, most of those processes start at the heart of our Verbund, the steam cracker. That's the part where you bring in, as of today, fossil feedstocks and you crack them down to the different materials and then you start to rebuild the plastics or all the other products that BASF is producing.
The plan BASF had was to feed the syncrude oil into their production process at the very beginning. But there was one more hurdle. You see, as far as some authorities were concerned, what came out of the gasification plant was still technically waste, which came with difficult rules and regulations, so shipment to the BASF plant was impossible.
So when we started that project, at a certain point we felt like running a marathon, but it's not just running all these distances, but it's also to stop every kilometer and to ask for a new permission to go ahead. And that was even more challenging because you needed another permission at every kilometer.
When you use waste material as an input material and then you make a product out of it, someone has to decide where the waste stops being waste. So this is not even that clear because, as I said, for us, from a scientific point of view and as technicians, it's quite clear that if I destroy my Lego piece and have the building blocks, then I have building blocks and then I can put them together however I want and have a new product. But from a legal framework, the waste has to stop being waste at some point. So we had even weeks of discussions with the authorities here in Vienna to get a permit, like a declaration for the end of waste of our product. Basically saying, now your product is not waste anymore and you can use it to produce a new product.
The team of BASF and BEST finally convinced the folks in charge that their product wasn't just another type of waste. It actually had some value. This was a big win, and they were finally allowed to ship it to the BASF plant in Ludwigshafen. BASF then converted this feedstock and was able to produce polyurethane for new steering wheels. So now that the team had proved that gasification of non-sorted, dirty plastic waste is feasible, it seems like a dream technology in many ways. So you might be asking, why aren't there already a lot more efforts to scale this technology up and bring it to market? Well, like a lot of things, that comes down to money. The process of steam gasification is energy intensive, and recycling plastics is generally a highly complex undertaking. And right now, it's simply much cheaper to use virgin plastics made directly from crude oil. Companies don't really have an incentive to buy products that are more expensive if they don't have to. One way to change this could come from the regulatory side. If there were laws in place that demanded the use of a certain percentage of recycled plastics, then steam gasification might be financially worth it.
What we need is really a regulation that pushes the whole market to use recycled materials, because then there is a market pull to get these materials. Then there is a willingness to pay. So to be fair, this is quite a way to develop. So recycled materials won't be cheaper than those that are coming from virgin materials or fossil materials. And therefore, we might have to think about the so-called EPR schemes, meaning extended producer responsibilities, where you pay the end-of-life step already when you buy a car.
And it's not just chemical companies that have their eye set on gasification. Other industries have their eye on this technology too.
To really understand the aim, we have to widen our view a little bit, because gasification is not only of interest for the plastics industry. There is a second industry that has a high interest, and that's the aviation fuels for planes and for ships both. Because they already have a legislation where they need to use a certain amount of biomaterials in their fuels. And therefore, they are building up gasification plants based on bio-waste or bio-feedstocks. And those plants will be there in the future. And compared to the need of feedstock that the plastics industry has, this is significantly bigger.
This is one of the reasons why Matthias is interested in a lot more than plastics when it comes to what he feeds his reactor.
I'm not only looking at plastics currently, so I'm still looking a lot of like biogenic materials. We're looking a lot into the production of sustainable aviation fuels based on biogenic residues. So this is still a very important part. And during my habilitation thesis, we also started to have projects here at BEST with our demonstration plant, where we already looked at first plastic fractions in mixed plastics with biomass. And all of these years of research then culminated into the demonstration that we did with BASF. So this is currently the last step in a rather long development, but a very big step towards developing this technology in this direction. So once you start this thought process, like there are a lot of like things that become a potential feedstock for your process.
Matthias doesn't see gasification as the end-all, be-all solution for mankind's huge plastic recycling challenge.
Even though we can use a lot of materials, a lot of them just don't make any sense because there are better ways to actually handle them. And we do not want to interfere with already existing very good recycling routes. So if there is already a route for a mechanical recycling, for example, or there is a route for chemical recycling that is very established and works very well, we don't see a need to actually position gasification as an alternative route. We would like to find all of these kinds of materials that don't have the luxury of having a technology set up for them yet. So we would like to be the ones that develop technology for recycling for these kinds of materials that do not have a technology yet.
It's maybe not the way how we use plastics, but it's a way how we trash them at the end of their life. So we really have to make sure that we probably collect those materials, because no one of us would like to see these polluted beaches. No one of us would like to see animals dying due to plastic waste. And therefore, we have to make sure that we have the right collection system. That would be the key.
This has been Substance, stories about the stuff that shapes our world. Substance is a podcast by BASF, produced by Territory Agency in collaboration with WakeWord and me, Joe Hanson. Research and scripting by Danielle Sedbrook, Claudia Doyle, Hardy Roda, and Joe Hanson.